viewers, in this lecture I'll be teaching you about the properties of solid state. As in previous lecture I've teach you about the solid state and its identification. So first of all, we know that the properties of solid state include its kinetic and molecular motion, its intermolecular forces, compression, diffusion, expansion, melting, and of course sublimation. Let's start with the kinetic and molecular motion. You all knew that a solid contains both kinetic and potential energy. So, kinetic and molecular motions are relatable in a way. In the solid, the particles are restricted to their original position and cannot move. The only vibration of the particles from the mean point is seen. Now, as you all know that the solid particles are bonded to each other, so they cannot move from one place to another, but still there is a movement because all the particle contains both of the kinetic and potential energy. So when they are heated, or we can say that when external energy is applied on that, so they move, but in the vibratory motion, and that motion is termed as kinetic and molecular motion. After that, intermolecular forces. Intermolecular forces are those forces between the two particles. So, the forces holding the solids and the liquid together are called intermolecular forces. The physical properties of solid and liquid due to intermolecular forces. The more the force, the more the bonding, the more hard the solid will be. So, the property of the hardness and softness depends upon the intermolecular forces. Apart from that, the attraction between the molecules is also intermolecular forces. Just suppose that we have NaCl. So, there is an intermolecular force between it, and that is termed as the bonding. After that, compression. It is difficult to compress a solid because the particles are compressed, or we can say that attached to each other. So it is difficult to compress a solid as compared to the liquid as well as gas. So here the compression depends upon the particles, and this is because the constituent particles in the solids are so closely packed that they either do not come closer or do so when very high pressure is applied. They can burst, we can say that damage, but still they cannot be compressed apart from some solids. After that, diffusion. Now diffusion happens when a solid is at the state where extremely slow process is going on, and solid particles have the lowest kinetic energy and so do not move. As a result, in case of solids, diffusion take a lengthy time, and of course if there is a, we can say that big time of diffusion basically means the appearance of the particles. So it depends upon the solid state, that at which state it is, which kind of it, so it depends upon the solid. Expansion is mostly due to the heating. So heating particles make the atom vibrate faster, and that cause it to move in the vibratory motion from its mean point, and the relative increases in the size of the solids when heat is therefore small. So it is also depend upon the solid properties, that how much heat it required to be expanded. After that, melting, we know that every solid has its own melting point. So here also heat is applied. Now let me tell you a difference, that melting and diffusion, we can say the expansion, has a huge difference. In the melting, we are changing the state of the matter. We can say that we are transferring it from the solid state to the liquid state or the gas state. But in the expansion, we are just increasing the size of the solid by applying mostly heat on it, or we can say that in some kinds of the solid also we can say that rubber-like properties of the material cause its expansion by stretching. So that depends upon the solid. So here the melting is mostly done by applying the heat on it, and from the pure crystalline solid it occurs at a specific melting point. Now we'll also discuss about the crystalline solids and amorphous solids in upcoming videos. After that, sublimation. Sublimation is a process from which a solid directly converts into a gas without changing into a state that is called liquid. So that process example can be the carbon dioxide ice gas, as you all have seen in program or weddings or something, that we are just showering some kind of a smoke. Now that's not a real smoke, but still that's the dry ice carbon dioxide. So here the carbon dioxide solid directly transfers into the gas without transferring into the liquid. So that is called sublimation. And that's all about today's lecture. Thank you.